Hello everyone, welcome to Shuatify. Today I'm going to briefly show you architectures that support web application scales from 1 user to 1 million users. As an example, let's assume we are building an e-commerce system. And yes, you can picture it like Amazon.com if it can make you catch up quickly. As we are focusing on traffic, scalability, and the architecture rather than some certain features, our e-commerce website only supports 3 features at this moment. User, which is user sign up and management. Product, that is responsible for product management. And order, which is transaction and payment. Keep the 3 features in mind. Let's start. This is the early stage of our website, just like Amazon in 1994. All applications, including database, are deployed to the same server. This is a simple start. As our website is up and running and is getting more popular, our traffic load is getting heavier as well. A straightforward remedy is upgrading the hardware of our server from 1 GB RAM to 1 TB RAM, from hard drive to SSD. This solution is called Scale Up. It's simple, but you will push it to the limit very soon. You will then realize that no matter how much money you'd like to pay, you can't get a more powerful server. Now it's time to switch to the scale out strategy, which is adding more machines and make them work together to support the ever-growing traffic load. In our case, the database and the web application code itself have different preferences for their hardware. For example, database requires a large storage and the web application needs faster CPU and a large memory. So we can deploy our database to a dedicated server. Now we have 2 servers, one application server and one database server. The 2 servers won't impact each other and they can scale independently. Our e-commerce website is so popular that one application server can't support our traffic anymore. Following our scale-out strategy, we can keep adding more application servers. But will they work together out of the box? Unfortunately, the answer is no. Now that we have multiple application servers, when a request comes in, which application server will handle it, and how it's determined. To solve this problem, we need to introduce load balancer into our architecture. The load balancer is sitting between users and our application servers, and it will triage the incoming traffic to different application servers based on different predefined strategies, like round robin. The load balancer can be dedicated hardware or more commonly software-defined load balancer. We will have other videos talk about a load balancer and its usage in system design interview. Please subscribe to our channel and you won't miss it. After adding more application servers, the only database server we are having right now will become the bottleneck when traffic load is getting heavier. Can we simply add more database server like what we did for application servers? The answer is no. Why? Imagine we have 2 database servers and both of them can accept write requests. Then we need to figure out how to sync up data and resolve conflicts between the 2 database instances. Otherwise, our data will be messed up. There are some complex ways to deal with this issue, but at this moment, we have simpler solution because in most scenarios, database read requests take up 80% or even more among all requests. Like when customers are browsing Amazon.com, they will view a lot of products before making decisions and placing an order. Based on this fact, we can keep a single database server that is dedicated to handle write requests and have multiple database servers that are dedicated to handle read requests. We call the single database server master database, and those database servers for read requests slave. The master database receives read requests and keeps sync it with slaves. Since master database is our single source of truth, and the slave will always accept changes from master database, therefore, we won't need to handle conflicts. The slaves are exact copy of master database, so we often call slave read replica in some cases. While our application keeps growing, there will be more repeated requests. For example, checking deals of the day. If we query database for each of these kind of requests, it's kind of a waste of our server resource because the result won't change for quite a while. So if we can cache the result and return it immediately when we receive the request, it can not only reduce response time, improve customer experience, but also save our server resource. There are several in-memory caches like Redis provide fast access to cache results. Our system scales from a single server that does everything to multiple servers that work together. The complexity of our system keeps increasing. It's extremely hard to maintain such a big monolithic system. The next step we will consider is to break the single application into microservices. For instance, we can have a user service, a product service, and an order service. Each of these services exposes a bunch of APIs to API gateway to provide service. API gateway is like a proxy. It's simply something that is sitting between client and the microservice to redirect traffic and do rate limiting, monitoring, and other tasks. The advantage of microservices are obvious. The complexity of each single service is reduced, and each service can evolve and scale independently. While microservices is not a silver bullet, it will increase the DevOps burden. Deploying the whole system composed of microservices requires much more effort compared with deploying a monolithic system. But luckily, there are a lot of DevOps tools to help this process easier. It's out of the scope of this video, and we will cover more details later. Putting it all together, we discussed how to change our architecture while our e-commerce website scales from 1 user to 1 million users. It's just a crash course on scalability. Don't worry if you're not familiar with some of the concepts at this moment. We will have follow-up videos cover more details. If you like our video, please subscribe to our channel. Thank you.